Good morning, scholars. I hope you have had a great week so far. As we enter into our Wednesday session today, just a couple of reminders. If you haven't finished the 2 assignments for solving systems using substitution, I suggest you hop on that. Those grades will start being processed and entered in today. And other than that, that is about it. Remember, on Friday, I'll reach out to those of you who have D's in the NG grade to figure out what we're going to do to get those taken care of. Nonetheless, so today we're going to do part 2 of solving systems, which is how to solve a system by elimination. Now, on day 1, we took care of substitution. Substitution is simply you have something that's either solved for x or solved for y. You plug it into the other equation, you work it out, and do that to get your 2 answers. Elimination works a little bit differently. Elimination works a little bit differently. So elimination is a process in which you want to get rid of one of the variables algebraically. So you want to literally, exactly what it sounds like, get rid of something. So for elimination to work, you're going to get one set of the variables to be opposites of each other and then add the 2 equations together to cancel them out, leaving you to add the remaining parts and solve for the first variable. Once the first variable is found, you can get the other by plugging the answer into either equation. So this is essentially what you want. So here's an example of what you want to have happen. 2x plus 5y equals 10. 4x minus 5y equals 2. So notice that the y's are opposites of each other. The numbers in front of the y's are opposites of each other. One of them is a positive 5, one of them is a negative 5. Since they are opposites, you're going to cancel them out, and you're going to add up the equations going down. So the 2x and 4x is 6x, 10 and 2 is 12. You could easily solve that equation to get what x is equal to, and then plug it back in to get y. This right here is what you want to happen for all of your problems for elimination to work. That's what you want to have happen. Now, in the problem that I drew up, those are already opposites, so you can just go ahead and get rid of them. Most of the time, you're not going to have opposites, which is going to require you to then have to multiply an equation in order to get it to work, which we'll be doing several examples of those as we navigate through the day. So, just a vocabulary note. The number in front of each variable is called the coefficient. It is those numbers that you need to be opposites in order for elimination to work. So when you hear me talk about a coefficient, I'm talking about the number that's in front of the variable. All right, so an elimination problem can present itself in many ways. We're going to illustrate the most common presentations that you'll see within this notes page today. So with that, let's start with example 1. So example 1 is the very, very basic case. So you've got 4x plus 3y equals 16, and 2x minus 3y equals 8. So this is the very basic case. If the coefficients of one of the variables are opposite, then they cancel out. So notice that the y's are already opposites of each other. Positive 3, negative 3, they're opposites. So what we will do is we will cross them out, and then everything else gets added down. Everything else gets added down. So that means 4x plus 2x is 6x. 16 plus 8 is 24. So that leaves you with an easy equation to solve. Divide both sides by 6 till x equals 4. So that takes care of your x value. To get to your y value, now you take the x value and you plug it back into one of the two original equations. It does not matter which one you choose. You should get the same answer anyway, as long as you don't do anything that's mathematically wrong. So we're going to take 4 and plug it into the first equation. So 4 times 4 is 16. Subtract 16 on both sides. You get 3y equals 0. Divide both sides by 3. Y equals 0. So that means your answer would be 4, 0. So remember, unless they tell you otherwise, write your answer as an ordered pair. Unless they tell you otherwise, write your answer as an ordered pair. So that's basic case. That's basic case scenario. Example 2. 2c plus 5d equals 10. 2c plus 6d equals negative 15. So notice this time, you don't have opposites, but one pet set is the same number. One of the variables has the same number in front. So when you have, in this scenario, if the coefficients are the same, you multiply one equation by negative 1 to make them opposites, then cancel the variables out. Now, in this case, we're looking at the c variable because they have the same number in front. Now, does it matter which one you multiply by negative 1? Absolutely not. You can multiply the top or multiply the bottom. That's 100% your choice. I'm going to go ahead and multiply the bottom by negative 1. So when you do that, the first equation you rewrite because you didn't touch it. Second equation, negative 1 times 2 is negative 2c. Negative 1 times 6, negative 6d. Negative 1 times negative 15 is positive 15. So if you notice, now you have the opposites that you need. Now the 2's are opposites each other. So they can cancel out, and you can add everything else going down. 5 plus negative 6 is negative 1. 10 plus 15 is 25. Divide everything by negative 1. You get d equals negative 25. Now you take that number and you plug it back into one of the original equations. Again, I'm going to use the first equation. Take negative 25, plug it in for d. So that gives you 2c plus 5 times negative 25 equals 10. 5 times negative 25 is negative 125. Add 125 to both sides, you get 2c equals 135. Then you divide both sides by 2. So now this is where your calculator comes into play. So you get c equal to 67.5. Make sure that's accurate. And of course, I'm making sure that my mathematics is accurate, as you should be doing as well with your calculator. 135 divided by 2, 67.5. So your answer is 67.5, comma, negative 25. And that's it, problem's over. And remember, take your time, it's not a race. Make sure you're doing your mathematics as accurately as possible. All right, so example 1, everything was already opposites. Example 2, we had to do a little bit of forcing. So let's look at example 3. So example 3, if the coefficients of both variables are not opposites, but one set of variables are multiples of each other, then multiply the smaller equation by a number that will make them opposites and cancel out the variables. A lot of wordage there, so let's show it in an example. So in example 3, first we look at the problem. As far as the x's go, 3 and 5 are not opposites. For the y's, 3 and 9 are not opposites. 3 and negative 9 are not opposites. So we can't cancel out anything right now. Now here's where your multiplication comes into play. You have to ask yourself, is there anything times 3 that will give me 5? Of course, the answer to that is no. So you move on to the next variable. Is there anything times 3 that will give me 9? Now the answer to that, of course, is yes. I can take 3, multiply it times 3, and get 9. So let's do that. Remember, if you don't have opposites, then you need to force them to become opposites. So we're going to multiply the top equation by 3. 3 times 3 gives you 9x plus 9y equals negative 45. The bottom equation we didn't touch, so we rewrite it. Now, if you notice, you've got the opposites that you need. So those drop out. 9 plus 5 gives you 14x. Negative 45 plus 3 is negative 42. Divide both sides by 14. You get x equals negative 3. So we've gotten the x value. Now we need to take care of the y value. For the y value, we go back to one of our original equations. You always go back to the equations that you started with. So we're going to take negative 3, plug it in for x. Then we start solving it from there. 3 times negative 3 is negative 9. Add 9 to both sides, you get 3y equals negative 6. Divide both sides by 3, you get y equals negative 2. So your answer here is negative 3, negative 2. That's it, that's all. Problem's over. So the key to that problem is if you don't have opposites, but you do have multiples, you can go ahead and multiply one of the equations to force the opposites to happen. Now, of course, the other end to that equation is very, very simple. What if there aren't any multiples anywhere? There aren't any multiples anywhere. Now what do we do? Let's look at example 4. So example 4. 3x minus 6y equals 9. Negative 4x plus 7y equals negative 16. So we look at the problems. The x's, 3 and -4 are not opposites of each other. The y's, -6 and 7 are not opposites of each other. No opposites, now we look for multiples. Is there anything times 3 that gives me 4? No. Is there anything times 6 that gives me 7? No. So there's no multiples. So in this scenario, you don't have opposites, you don't have multiples. Now we're going to do something known as pick and switch. Pick and switch means pick a variable and switch the coefficients. Pick a variable and switch the coefficients. So you can pick whatever variable you want. I'm going to pick x. So pick a variable, switch the coefficients, which means I'm going to take the top equation and multiply it times 4. Take the bottom equation, multiply it times 3. Now I'm going to force them to become opposites of one another. I'm going to force them to become opposites. So let's make that happen. 3 times 4 gives you 12. So that's 12x minus 24y equals 36. And for the second equation, you have negative 12x plus 21y equals negative 48. So now if you notice, your x's are now opposites of each other. Your x's are now opposites of each other. Remember, you need the same number, one of them being positive, one of them being negative. So that's what you always want to have happen. So you've got your opposites, so they drop out. You add everything else going down. Negative 24 plus 21 is negative 3y. 36 plus negative 48 is negative 12. Divide by negative 3, you get y equals 4. There's half of your answer. To get the other half of the answer, take your answer, take your first value, plug it into whichever equation you want. You see, I'm loving that first equation. Take 4, plug it in. 3x minus 6 times 4 equals 9. 6 times 4 is 24. Add 24 on both sides. 3x equals 33. So x equals 11. So your final answer for this problem is 11, 4. 11, 4 gives you your final answer. Again, not a difficult problem, but it's one in which you've got to pay attention a little bit more to what you're doing. Pay attention just a little bit more to what you're doing. All right. So the last two examples are examples when the variables are not in order, are not set up. With examples 1, 2, 3, and 4, everything has been set up for you and ready to go. 5 and 6, however, they're not set up for you. So when you do elimination, all the variables need to be on one side of the equation, and they need to be lined up on top of each other. If that's not the case, then rewrite the equation so that this is happening. Then you can proceed with solving it out. So if you look at example 5, blow this up just a little bit. If you look at example 5, notice the first equation has x and y on the same side, but the second equation does not. So you need the variables to be on the same side. We can fix that, though. We're going to take the 2x and move it over to the other side. But that means you got to subtract 2x on both sides. So your new setup will be 2x plus 6y equals 17, and negative 2x plus 10y equals negative 9. Now that it's set up, you can start solving it. And of course, if you can see, as you see, everything's now set up and ready to go. So we can go right ahead and start solving it. The two x's are opposites of each other. They drop out. 6 plus 10 is 16y. 17 and negative 9 is 8. Divide by 16. Y equals 1/2. So y equals 1/2. Take your answer, put it into whatever equation you want to solve for x. So 2x plus 6 times 1/2 equals 17. Half of 6 is 3. Subtract 3 on both sides. 2x equals 14. X equals 7. So your answer is 7, 1/2. Or you can use 0.5 if you wish to use 0.5. So again, it wasn't a difficult problem. The main thing you have to keep in mind is the variables have to be on the same side and they have to be lined up. Variables have to be on the same side and they have to be lined up. So our last example for this section is example 6. So again, we're still using elimination. However, you need to look at the problem first and make sure the variables are all on the same side. The top equation you see isn't cooperating. So this 3x has to move over. So we're going to have to subtract 3x on both sides. So that gives us 2y minus 3x equals negative 9. And 4x plus 5y equals 35. Now, before you go any further, I want you to notice something. The x's and the y's are not on top of each other. So we can't start this problem yet. We need the variables to be lined up. And we can easily fix that. So the top equation, we want the x's lined up on the, we want the x's coming first, so just switch them. So that's negative 3x plus 2y equals negative 9. Now everything is set up and ready to go. Everything is now set up and ready to go. Again, you want the variables on the same side, and you want them lined up. So now let's go to work. Use a different color here. Negative 3 and 4 are not opposites. 2 and 5 are not opposites. So now let's look at multiples. There's nothing times 3 that will give me 4. There's nothing times 2 that will give me 5. So now we do the pick and switch. Pick a variable, switch it. So this time I'm going to eliminate the y variable. I'm going to eliminate the y variable to illustrate to you that sometimes you can multiply by a negative number and still make this work. So since I'm getting rid of the y's, I'm going to multiply the top equation by 5 and the bottom equation by 2. You're picking the variable and you're switching the coefficients. But notice that 2 times 5 is 10, positive 10. 5 times 2 is positive 10. Remember, opposites mean one of them is positive and one of them is negative. So that means you're going to have to make one of these two numbers, the 5 or the 2, a negative. Which one you make negative? Completely up to you. So I'm going to make the top one negative. Remember, you need opposites. You always need opposites. So now let's multiply it out. Negative 3 times negative 5. Move it up here. Positive 15x. 2 times negative 5. Negative 10y. Negative 9 times negative 5. Positive 45. Bottom equation. 4x times 2. 8x. 5 times 2. Positive 10y. 35 times 2. 70. So you now have your opposites. They drop out. Everything else adds up going down. 15 plus 8 is 23. 45 plus 70 is 115. Divide by 23. You get x equals 5. You get x equals 5. Now we go to get y. So to get our y variable, we go back to our originals. So of course, I'm always loving that first equation. Take your 5, plug it back in for x. So 2y equals 15 minus 9. 2y equals 6. Divide both sides by 2. You get y equals 3. So your answer is 5, 3. 5, 3 is your final answer. So again, the hardest type of elimination is when you have no opposites and no multiples, but it is one that can be easily figured out and solved out. And with that, that finishes up our look at elimination. Remember, the purpose of elimination is to get rid of a variable. Get rid of a variable. Either they'll already be set up and you can go cancel them out, or you'll have to multiply by something and then cancel them out. Either way it goes, they got to go. Either way it goes, they got to go. That's how elimination works. So you'll have an IXL assignment to give yourself that practice, and then you'll have a Google mini quiz to show your stuff. Of course, if you have questions, please make sure you reach out and ask. On Friday, we will have live video office hours for those of you who wish to pop in and get questions answered. But other than that, I hope you have a great Wednesday, and I'll talk to you later.